Okay, guys, we're back again. This is the last section of Chapter 7. I don't know if it's felt like it has steamrolled you over or not. Hopefully not. Hopefully we've taken enough time in class and with several worksheets and assignments and so on that you've been able to keep up with this and understand it. So we're going to throw one more thing at you with trig here. Kind of the most complicated thing you can do with this form of trig anyway. And so now, maybe it doesn't seem like that big of a deal, but now they're going to give us the sides. We need to be able to find the angle measure. I don't know if you've noticed that, but all the ones we've done so far, they've given you the angle measure, 30 degrees or 65 degrees or whatever. Now we're trying to find the angle measure. And so really, it's just algebra. It really is. It's just algebra, and the trig ratios are just one of the operations that we're using. And so in this case, they want us to find sine A. And take this video as just an introduction to this. We're going to explain a little bit more in class, and as we do problems with this, it's going to make more sense. But they're asking us here to find sine of A, which is a ratio, as a fraction and as a decimal. And so if we're looking at angle A, down there in the bottom right-hand corner, and we want sine, remember sine is opposite over hypotenuse, and so the sine of A here is going to end up being 3 over 5, right? The opposite side's 3, hypotenuse is 5. So there it is as a fraction. That's easy. That's what we've been doing. And as a decimal, you would just divide that. So 3 divided by 5 comes out to be 0.6, okay? Or, well, yeah, it comes out to be 0.6, okay? Now, to actually find the angle to the nearest degree, so is that a 22 degree angle? Is it a 58 degree angle? What is it? We're going to use the inverse function buttons on your calculator, okay? And you need to understand, now probably in Algebra 1 you didn't really talk about inverse functions. It's kind of an Algebra 2 concept, but just try to take what we're talking about here. You know opposite operations, and that's pretty much what an inverse function is here. So, so see what's going on here. So here's our equation from up above. Sine of A is 3/5. Well, we're trying to solve this for A. We want to know what angle A measures, and so that's our variable. Well, sine is an operation. It's not like a number sitting out there or whatever. It's an operation. And so this would be kind of like having like a radical. A is equal to 3/5. How would you get rid of that radical? Well, you would do the opposite. You would square both sides. If it was, if there was a number out there, if it was 3 times A, you would do the opposite. You would divide by it. And so we have to have something that is the opposite of sine. Well, the opposite of sine is the inverse sine. And so what we're going to do here is we're going to take the inverse sine of both sides of this equation. And the inverse sine looks like this. It looks like it's sine to the -1, but that is not an exponent. This is just notation. The notation here is inverse sine. That's the way you read that. Well, if we take the inverse sine of that side, in order to get rid of that sine, because those are opposites, we have to take the inverse sine of the other side, right? When you do one thing to one side of an equation, you have to do it to the other. So the inverse sine of the other side, and so on the left-hand side, the inverse sine and the sine cancel each other, just like a square and a square root or whatever. On the right-hand side, we have to actually find the inverse sine of 3/5. And so on the right-hand side, we just get measure of angle A. We just get A by itself. And if you take this and plug it into your calculator, and we'll talk about this in class, but you have a second button, or some calculators have different things there.
They might have them all in the front.
Inverse, or yeah, it could even just have a sine inverse key right there. So you need to find that key on your calculator and go inverse sine, wherever that key is, and then parentheses. It should set up a parenthesis for you. 3 divided by 5, close your parentheses, and hit equals. And you should come up to about 37 degrees. It may have rounded here, but it should be somewhere around 37 degrees. So you need to try that with your calculator right now and make sure that you can see how to use the inverse sine key on your calculator. All right?
All right, so now we're going to try it again, and we're going to try to find the measurement of angle B to the nearest degree. So once again, guys, you got to just kind of, look at what you've got, and from where angle B is at, okay, that's what I don't know. I have the opposite from B, and I have the adjacent to B. So once again, we want to use tangent. So when we go to set this up, all right, we're going to round this to tan B. Oops, excuse me. We're going to set this up as tan B. All right, tan, the angle of B, equals, okay, opposite over adjacent, so 15 over 8. And notice I leave that space there. And that's a good thing when you do this on your paper, because we always want that inverse function to go in front of that fraction, not behind it. Okay, so that's why they have that space there, guys. So when you're writing these up, I would do the same thing. Put a little space between that fraction and the equal sign, so that when you go to put inverse tan on the left to cancel it out on the left side, and then you go put it on the right, that you're putting it right in front of that fraction. And so then all you got to do is pop that into your calculator, tan negative or tan inverse tan, 15 over 8 in your calculator. Hit enter, and you'll get that the measurement of angle B is 62. Now I just want to point out that some of the questions in the book are going to ask you, hey, what's the other angle?
Oh yeah.
I don't need to go back and do any sign or anything like
Yeah,
that.
the
Just
same
remember, guys,
calculation again.
triangles have 180 degrees. That's it. So if I know angle B is 62, then angle A has to just be 28.
Right.
And that's an important thing because sometimes they're going to say solve this triangle,
Right.
and you're going to have to do all that stuff. So
Yeah,
we'll
you
probably
don't
get to
wanna
that
do
here
it
in a
twice,
minute.
you
But
can just get it quickly.
yeah, just think,
Yep.
critically think a little bit. Use some common sense. Anyways, keep moving forward here. So try these to the nearest degree or to 4 places. So basically, guys, instead of seeing it as a fraction, you're seeing a few of these as a decimal. And be careful because there's, you just got to pay attention to what they're giving here. So if I see cosine of angle W equals 0.5736, all I got to do is do inverse cosine of both sides, and I get that the measurement of angle W is 55 degrees. So remember, you got to go inverse cosine on your calculator, and then plug in the decimal, and then hit enter. You should try these on your calculator as we're going through them and making sure that you're getting the same thing we are. Because if you don't, you're doing something wrong. And this is a good chance to really practice this.
That's what these are for, is just calculator practice.
Yeah.
So get your calculator if you don't have it right now.
Okay, now the next one is a little bit different. Okay, so now they're telling you tan y is 57.29. So y is the angle measure. So we're going to go inverse tan 57.29. Oops. All right, so they're going down on me. So rewind. So sine 38. Now look, pay attention to what they gave us here. They gave us that the angle was 38 degrees already. So when you go to do this one, you got to set up your proportion, all right, and you're going to cross multiply, and you're just going to pop in what sine 38 is in your calculator.
Yeah, this one's just a straightforward
calculation.
calculation.
It's saying that x equals sine 38, guys, so just plug in
38.
sine 38, and you get approximately 0.6157. You get the factor more than anything else.
Right.
And then now let's go to that tan one. Remember, it was going to be just inverse tan, 57.29, and you get 89 degrees for that angle. And then on this one, now be careful on this one. They're giving you cosine -1 and then times 0.6293, or basically cosine -1.629. So just same thing. Z is approximately that. Just write it as you see it because they're giving you the factor here, and then you're going to get angle Z is about 51 degrees.
Yeah, they've kind of already done the first step for you, taking the inverse cosine of both sides.
So they're just trying to get you to see some different ways that you may see it, and they're trying to say, hey, do you know what to do based on the information that you're given? And that's why I said to try these, with your calculator as we're going through them.
Yeah. Okay, so here's kind of the major thing that we've been trying to get to, is being able to solve a right triangle. Solving a right triangle means to find the measurements of everything that's missing angles and missing sides. So notice in this one, they just give us 2 sides. They expect us to be able to find the third side, and they expect us to find the 2 other angles besides the right angle. And you can do that. That's what Trig allows us to be able to do. Okay? And so probably the easiest piece is to be able to find the angle up there as R. We'll find the angles first. Easy piece to find is the other side. But anyway, cosine R is 12 over 15 because cosine is adjacent over hypotenuse, and those are the 2 pieces that they gave us. So if we're going for R first, we would use cosine. And so if you solve that, it would be inverse cosine of both sides to get the R by itself. And so inverse cosine of 12 over 15 in your calculator would give you about 37 degrees for angle R. Now, as Mr. Bedella was just saying, I'm not sure if this slide is going to do this or not, but you don't need to go through the whole calculation again to get T. All we got to do is subtract 37 from 90 because we know they're complementary. Okay, and so the other angle is going to end up being 53 degrees. Okay, so you need to be able to see that. And how are we going to get the third side? Mr. Bedella.
I see a shortcut.
What's that?
Pythagorean triple.
Okay. There's a Pythagorean triple here, right? and we're going to use Pythagorean's theorem to find it. And so if you know your triples, this is easy, right? But if you don't know your triples, okay, then you would just plug into Pythagorean's theorem, a squared plus b squared equals c squared, and solve that, but you would end up with 9. And so what triple is this?
This would be a 3, 4, 5.
Tripled.
That's right.
It's a 3, 4, 5 triple. Okay?
I love 3, 4, 5s.
Yes. They show up a lot. They show up all the time.
Know those triples, man. It saves some time. All right, so we're going to solve another one here. So They want us to solve the angles to the nearest degree and the sides to the nearest tenth, so basically the same thing. So let's see which one they want me to find first. All right, so they want us to find the measurement of angle J. So if I want to find the measurement of angle J, I have the opposite and the hypotenuse. So I'm going to use inverse sine here, guys. So when I do that, I get sine J equals 16 over 20. Take the inverse to both sides. So inverse sine 16 over 20, and I get approximately 53 degrees. And now if I just subtract 90 by 53, I get 37. Easy peasy, lemon squeezy. And then if I use, Pythagorean's theorem again here to find my third side, or
if I knew the shortcuts.
If I knew the shortcuts, I know that, 5 times 4 makes 20, and 4 times 4 makes 16, so that long legs of 4, the hypotenuse is of 5, so, hey, I got another 3, 4, 5 triangle here.
There you go.
So all I got to do is go 3 times 4, because that's how I got to the other ones, and then I get 12, and we're done.
Yep.
Gotta love those triples.
Yep. All right. So that's how you use inverse sine was the main thing in this lesson. And so, again, we'll talk a lot more about it in class and make sure you know how to use your calculator for that. All right. That's chapter 7. It's a wrap.
It's a wrap.
We'll see you in class, guys.